Hey, welcome back. We'll go over another problem. This was a very difficult one. This is P2876. And first thing we do when we solve problems, right? We go to numbers. Excuse me. Numbers 1,000 cubic feet. I see 281 degrees Fahrenheit and 35. Oh, look at that. Pounds gauge, right? So I know, and I'm not going to sit here and figure it, that 35 pounds gauge is 50 PSIA. So I'm going to write that right there. There's another number, 100% quality. That's important information. And here's a number, 0% quality. 0.1% design flow. And 100 pounds mass. I may have to change these Fahrenheits to Rankine, but I don't think so with this problem by looking at it. Refer to the drawing of two 1,000 cubic foot pressure vessels with installed relief valves. See the figure below. Okay, 1,000 cubic feet each. Vessel A and Vessel B. Both vessels are in saturated conditions at 281 degrees Fahrenheit and approximately 50 pounds. Absolute. Vessel A is completely filled with saturated water. Vessel B contains 1/2 saturated steam with 100% quality and 1/2 saturated water with 0% quality by volume. Both vessels are protected by identical relief valves. If both valves begin to leak at a rate of 0.1% design flow, I guess that's just a way to tell us that isenthalpic. Spelled that wrong. I guess just that's a way to tell us it's isenthalpic. The higher temperature fluid will initially be leaving the relief valve of vessel blank. Okay. And if 1,000 pounds mass of fluid is released through both relief valves, a larger pressure decrease will occur in vessel B. All right, so first off, I'm looking at it, and 100 pounds mass of steam coming out and 100 pounds mass of saturated water. All right, they're at saturated conditions. They're both going to lower their pressures. All right, so the steam is going to lower its pressure. The water is going to release some water. The water vessel A is going to release some water, and then some of this water is going to flash to steam, and it's going to be less of a pressure drop, if that makes sense. So this will be the larger pressure drop here. So I'm going to say that B is the right answer for the pressure drop. And since enthalpy of vessel A is going to be lower, it's going to be the H sub F at 50 pounds. The enthalpy is going to be H of F here, and then H sub G here. And might even be superheated. So I'm going to say that B is going to be the higher temperature, and A is going to be the lower temperature. So let's see if I'm right. And I know you're all thinking that, of course I'm right. I'm doing this. But we'll prove it. So if you go to your superheated steam tables on page, that'll be the top of page 16. All right. 50 PSIA has a Tsat equal to 281 degrees. And it has an enthalpy of saturated liquid. And that number is equal to 250.23. That's going to be in BTUs per pound mass, of course. And enthalpy of saturated steam at 50 PSIA is going to be equal to, let's see, 1174.2. 1174.2 BTUs per pound mass. Okay. So that's our escaping enthalpy. So we'll call it enthalpy at tailpiece A is going to be equal to 250 BTUs per pound mass. And the enthalpy of the tailpiece at Bravo is going to be equal to 1174 BTUs per pound mass. Now they're going to a pressure is equal to atmosphere, right? Equals 15 psi. So the enthalpy of saturated water, saturated liquid at 1.5 psia is equal to 181.18 BTUs per pound mass, and the enthalpy of saturated steam at 15 psia is equal to 1150.7 BTUs per pound mass. Alright, so everything in between 181 and 1150.7, that's going to be wet vapor with some quality. Alright, so I'll put this, since H sub tailpiece A is less than 1174 BTUs per pound mass, and enthalpy of tailpiece A is greater than 250 BTU, 250.23 BTUs per pound mass. So temperature at tailpiece A, we'll go at tailpiece A is wet vapor at Tsat equals 281 degrees. Alright, since enthalpy at tailpiece B is greater than 1174 BTUs per pound mass, it is actually, greater than 1150. So 1174, that's the wrong number, sorry. It's greater than 1150 BTUs per pound mass, and I'm getting that right here for the saturated steam enthalpy at 1.5 pounds. Superheated vapor, that's what we got. Alright, so there's wet vapor coming out here, and then there's superheated vapor coming out here. So it's definitely going to be hotter. So temperature at tailpiece on B tank is hotter. Well, how do we find out how hot it is, right? How hot? Go to 15 pounds on page 1515 of your steam table, and you start looking at enthalpies of superheated steam. All right, so I could tell enthalpy of superheat 15 pounds at 240 degrees is equal to 1163.9 BTUs per pound mass. Enthalpy superheat of 15 pounds, 280 degrees Fahrenheit is 1183.1 BTUs per pound mass. So what do you think the enthalpy is at 260 degrees? What is that enthalpy? I'm going to say it's around 1173, 74. to 1174 BTUs per pound mass. And hey, look, that's what the tailpiece temperature is for tailpiece problem. So I'm going to say the temperature at tailpiece, the temperature for tailpiece Bravo is equal to approximately 260 degrees. Certainly hotter than that's going to be greater than 212 degrees, which is the saturated, which is equal to Tsat at 15 psia. So we got that. Oh, I think I wrote that wrong. Excuse me. So tailpiece A is wet vapor at a Tsat of 281. That is not correct. All right, it's going to be a saturation temperature of 212 degrees Fahrenheit. It's a saturation temperature 15 psia. So sorry about that. We'll go ahead and get that off the screen. 281 is the saturation temperature at 50 pounds instead of 15. All right, that's why I think it's important to label all this stuff. Look, I messed this up too. Since enthalpy of the tailpiece at alpha tank is less than 1174 and greater than 250, and that's not true. It's these two temperatures here we're worried about. These two enthalpies we're worried about. So this is not correct. This will be 1150.7. Sorry about that. Mind is distracted. So, does everybody understand that the steam coming out is going to have or the water coming out is going to have an enthalpy of 250, and that's going to be in between here and here, the saturated steam and saturated water enthalpies at 15 pounds, 15 pounds. And when it comes out here at tailpiece B, it's going to be superheated because it's greater than this number right here. How superheated? Well, about 260 degrees if you look at the superheated steam tables. All right, so now the thing we do with the problem is we say, and if one, well, first, the higher temperature fluid will initially be leaving the relief valve of vessel B. So we're going to look here. It's not A. It's not A. It's either C or D. Okay. And now, if 100 pounds mass of fluid is relieved through both relief valves, the larger pressure decrease will occur in vessel G. All right, can you just intuitively see it's going to be the steam? Because it's going to take all this energy to turn the water into steam, which it's going to do because it's going to lower pressure and turn into water. It's going to flash. And you're just going to get a bigger drop because you don't have to turn any of this steam into steam when you lower pressure. So a better way to put it is look up the specific volumes. So the specific volume of water at 50 psia is equal to, and I'm looking on page 16, it's going to be 0.017268 cubic feet per pound mass. Now the specific volume for saturated steam at 50 psia is going to be equal to 8.5171. 8.5171 cubic, doggone it, excuse me, cubic feet per pound mass. So now we can find the total mass in the tank. So if you look here, the problem said there's 1,000 cubic feet in this pressure vessel. So if we take the mass of tank alpha is equal to 1,000 cubic feet. Now you divide that by the specific volume, 0.017268 cubic feet and this is cubic feet up here, per pound mass. So if you then go cross out your cubic feet, you will come up with a pounds mass number, right? And that number is going to be 1,000 divided by 0.017268. 57910.6. 57910.6 pounds mass. Now, I want you to think about this. There's going to be a much bigger number than the steam, because the steam takes up so much more space in B. Okay? So this can lose 100 pounds. It'll be 57,810.6 pounds mass. All right, but let's look at the mass of B. And that's going to be equal to, well, it's 500 cubic feet of steam and 500 cubic feet of water. 1/2 saturated steam at 100% quality and 1/2 saturated water by volume. So, since we have 500 cubic feet, divide that by 8.5171 cubic feet per pound mass. I know here the cubic feet are going to cancel out, and I'm going to come out with pounds mass. So that number of just the steam, now there's water in there as well, it's going to be 500 divided by 8.5171, 58.7. 58.7 pounds mass. We are taking 100 pounds mass out. So we are taking all the steam, all the initial steam, from Bravo. And then 41.3 pounds mass of the water here is going to have to flash. You just can't see it. There's a way to figure this out by calculating the entire enthalpy. And I don't see a real need to do that. I don't see a good way to calculate the exact enthalpy that's in this after you drop it to 15 pounds, because you don't know how much steam got out, how it acted when it got out. But I think it's just better to look at this as an intuitive thing. All of your steam left. Yeah, you let 1,000 pounds mass of water, which took up a space of, or 100 pounds mass of water took up a space of V sub F equals 0.017268 cubic feet per pound mass. That 100 pounds mass, I'm sorry, that goes, yeah, no, that goes up here. That 100 pounds mass of water, I mean, that took up, what is it, 1.7268 cubic feet? And it took up the entire 500 cubic feet. That's in tank A. And it took up, and that versus the 500 cubic feet from tank B. So it didn't get rid, so at the end of the day, there was steam still in tank B. It was just very wet, much wetter than it would be at a very low pressure, very much more less of a pressure than just the 100 pounds. The 1 cubic feet of space you made in here that's now captured with steam. Now there's 500 cubic feet in this one. I hope that made sense to you. And I know it's a little confusing, but D is the correct answer. Vessel B has the hotter relief valve temperature, and if 100 pounds mass is released through both release valves, the lower pressure decrease will occur in vessel B. So thank you for watching, and that is all I have to say to you people.